So today we're going to be going over the notes for target 1 of the Pythagorean Theorem. And by the end of this lesson, you should be able to use the Pythagorean Theorem to find a missing side and also be able to determine if triangles are right triangles or not. So a right triangle is a triangle that has an angle that's 90 degrees. And that 90-degree angle is usually shown with this square inside the triangle. And the two sides adjacent to the right angle, or the two sides that help form that right angle, are known as the legs. And in our formula, they're going to be A and B. The side opposite the right angle is called the hypotenuse. And you can see it's the side that's all the way directly across from it, and how it's the side that doesn't form the right angle at all. And this side is always the longest side of the right triangle. In any right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. And then we can come up with our formula based on this. So we take this side A, and we do A squared plus side B squared, and so that'll equal C squared. And to prove if triangles are right triangles, we take the Pythagorean Theorem converse. And so the converse switches the order of the if-then statement. And so we know if A squared plus B squared equals C squared, then the triangle is a right triangle. So now let's take what we just learned and label A, B, and C on the following triangles. So I usually start with labeling side C because it's easier to notice because it's the side that doesn't form the right angle. So in this first triangle right here, I know that C is directly across from that right angle, so I'm just going to label it with a C. So that tells me that the other two sides are A and B, and it doesn't matter which side you label A and which side you label B, as long as you're labeling C correctly. So I'm going to label the longer side A and the shorter side B. And I'm going to do the same thing with the next triangle. I'm going to look at that right angle and look directly across from it and label that one with a C. And then the other two, it doesn't matter which one's A and which one's B. Again, look directly across from that right angle, label that one C. And then label the next two sides A and B. And by now you guys should be used to finding out which one is C, and the other two sides are going to be A and B. So now we're going to use what we've learned about labeling triangles and also the formula, and use that to find the length of the hypotenuse. And so we have a few steps that we take when doing this. So first we're going to label A, B, and C. Then we're going to square both sides A and B, or both of the shorter sides. Then we're going to add those two squares together. And lastly, we're going to take the square root to find the length of C. So here I have this triangle, and I labeled C right here. So now I'm going to define what A, B, and C are. So I'm going to say that A equals 6, B equals 8, and then I'm going to label C with just a question mark, because that's the side we're solving for. Next, I'm going to find the value of A squared and B squared. So all we're doing here is we're just going to square the lengths of the sides. So A squared equals 6 squared, and B squared equals 8 squared. Lastly, I'm going to solve for those values. So we know that 6 squared is equal to 36, and 8 squared is equal to 64. Now we can use our formula that we know, where A squared plus B squared equals C squared. And all I'm going to do is take this value for A squared and plug it into the formula. Take this value for B squared and plug that one into our formula. And then we're going to leave C squared alone, because that's the side we're solving for. Next, we're going to take the sum of those two squares, which is the second step in our formula. And so 36 plus 64 equals 100, which equals C squared. And lastly, we just take the square root of both sides. So we take the square root of c squared and the square root of 100. And we know that the square root of 100 is equal to 10. So 10 equals c. And that's our final answer. So then the next two problems you guys can do on your own, and then they should be in the answer key in the binder. So now we're going to use the Pythagorean Theorem to find the length of a leg. So it's very similar steps, but instead of adding the two squares together, we're going to subtract the smaller square from the length of the hypotenuse squared. So first we're going to label A, B, and C just like we did in the original problem. So A equals, B equals, C equals. In this case, I labeled that side A, so A is going to equal the question mark. B is going to equal 60, and C is going to equal 68. So now we're going to find what B squared equals and C squared equals. So B squared equals 60 squared, which equals 3,600. And C squared equals 68 squared, which equals 4,624. Next, we're going to use our formula and plug in our variables. So we have A squared plus B squared equals C squared. In this case, we leave A squared alone. We're going to add 3,600 because that is the measure of B squared. And then we can say that equals 4,624 from the measure of C squared. Now we can subtract 3,600 from both sides because that's the length of the smaller square. So now we can say A squared equals 1,024. And lastly, just like how we did in the previous problem, we're going to take the square root of both sides to solve for the length of A. So then we're left with A equals 32. And then that's your final answer. So now we're also going to use our formula to help show if triangles are right triangles or not. And so they have similar steps again. You're going to label A, B, and C, but this time you're going to square all the sides and then see if A squared plus B squared equals C squared. So if A squared plus B squared equals C squared, then we know that the triangle is a right triangle. But if A squared plus B squared does not equal C squared, then we know that the triangle is not a right triangle. So first I'm going to label my variables again. So I'm going to say that A equals 3, B equals 4, and C equals 5. Next I'm going to do the same thing that I've been doing and saying A squared, B squared, and C squared equal the squares of their lengths. So A squared equals 3 squared, B squared equals 4 squared, and C squared equals 5 squared. And then we can do that out and say 3 squared equals 9, 4 squared equals 16, and 5 squared equals 25. Now we're going to write down our formula, A squared plus B squared equals C squared. And then we're going to plug in all these values. So we're going to say 9 for A squared plus 16 for B squared equals 25 for C squared. And then this time, instead of just doing a regular equal sign, we're going to do an equal sign with a question mark above it because we're not really sure if it equals it yet until we get to the end of the problem. So then we have to add up sides A squared and B squared together and see if it equals the length of C squared. So 9 plus 16 is 25, and that's the side that we're trying to solve for. So because A squared plus B squared equals C squared, it is a right triangle. So then we're just going to write right. If it wasn't right, you'd either write not right or no. But then at the end of this, we're going to put a little check mark notifying that we solved the whole problem. And Then again, there's 2 problems for you guys to try in a row, and those answers are also in the binder. And you guys know that Ms. Leary and I are here to help you guys throughout. Let us know if you guys have any questions.